Hi, I'm Len Epp from LeanPub, and in this LeanPub Frontmanner podcast, I'll be interviewing Zach Tellman. Based in Oakland, Zach is a software engineer and consultant who works on projects where he takes on the roles of newly hired principal systems engineer or architect, or where he provides recurring guidance and mentorship to software engineering staff. He also has released a number of open source libraries and is a popular conference speaker. Zach is the author of the LeanPub book Elements of Clojure, which is meant for readers who know and use Clojure and want to use it more effectively, and to give teams a shared vocabulary for their Clojure-related discussions. You can read Zach's blog at ideolalia.com and follow him on Twitter at ZTellman, or Z Tellman, I should say, speaking to an American. And you can check out the dedicated website for his book at elementsofclojure.com. In this interview, we're going to talk about Zach's background and career, his professional interests, his book, and at the end we'll talk a little bit about his experience writing his book. So thank you, Zach, for being on the Front Matter podcast.
Thanks for having me.
I always like to start these interviews by asking people for their origin story. So I was wondering if you could talk a little bit about how you grew up and how you first became interested in computers and software.
Sure, yeah. So I grew up in the Bay Area, haven't escaped very far, and I played around with computers when I was younger, and I started to get, more seriously into the question of how to actually create software on my own when I was in high school, and decided that I really wanted to major in computer science. And so I went down to Southern California, studied computer science, and around my third year, I very nearly dropped out because there was something in software that really resonated within me, that made me excited, that made me want to dig deeper into it. But the coursework that I was doing didn't evoke that in me. And I remember I was doing a course on compilers where they were doing this very tedious recursive descent parser where you had to just write all these things that were not hard but very particular. And I realized that if this is what my job was going to be, I was going to hate my job. And so I just stopped going and started to kind of look around and understand what else was there that might more reliably sort of evoke this sort of resonance. And so through that, I came to the point where I had effectively a minor in philosophy and creative writing before I realized that in everything that I looked at, there were pieces of it that really interested me and a great many other pieces that didn't. And I kind of tried to be as responsible as I could in evaluating all of my options. And it seemed like there were the most paths and most varied paths towards success in software. To succeed as a writer, to succeed as a philosopher was a very, very sort of narrow and difficult path to really successfully go down. And so I went into my first job sort of tentatively, not really quite sure what to expect. And it turns out that it was closer to really what I had done on my own than to what I did in my courses. And I kind of kept on pushing off in that direction. But there had been something that I kind of noticed, which was that I would have these moments of sort of recognition in something, right? Where something, as I said, it resonated. It was sort of a recognition of something in myself for a moment, sort of outside of myself. And I had this with some things in software, with some philosophers, with some writers. And I would try to explain them to other people, right? I would get very excited and I would start sort of trying to articulate this thing that really spoke to me. And, 90% of the time I would completely fail, right? Because whatever it was, either it wasn't, didn't mirror something inside the person I was trying to explain it to, or I was just very bad at explaining it. And in software, this kind of intuition I had, this aesthetic sort of reaction I had to it, was a pretty effective guide for how to create software. But the two problems were that it wasn't always effective, right? Sometimes my intuition would mislead me, but also, again, I was really unable to articulate effectively to somebody else why it was that I thought that, we should go and do X instead of Y. And as a junior engineer in my first job, the issue was that I would say emphatically we should do this and not this other thing, and people would, ask me why, and I wouldn't be able to say, and we wouldn't end up doing that. And then later in my career, I would say this, and someone that I was mentoring or supervising would ask me why, and I wouldn't be able to explain it either. I mean, they would do it, but I wasn't able to actually give any sort of reasonable explanation for what it was that I felt very strongly was sort of the right thing to do. And so, through my career, about 4 years in, I found a language called Clojure, which again spoke to me, right? There was a sort of recognition of something that reflected something in, how I thought about software. And I went very deep on it, and I was able to get jobs and work with it and, create open source software. But still, there was kind of this unanswered question in my own mind, which was, why, right? Why this? Why not this other thing? And Clojure being sort of a relatively new language when I started it, people would often ask me, expect me to play the advocate for that language, or for how I chose to use that language, or, any number of other things. And my best sort of most concise answer was, it just fits my brain.
Yeah,
and
I wanted to take the opportunity to ask you about that there. For people who are listening who might not be aware of what Clojure is, if you could explain a little bit about it, where it came from, and then I'm really interested in hearing what it was that you found a reflection of yourself in it.
Yeah. So Clojure is a language in the Lisp family. The Lisp languages started back in the 50s and have been this sort of very sort of sideshow within the whole pantheon of languages, where there are many languages that were very seen as very practical, seen as very workmanlike, and Lisp were always just sort of off to the side, often in academia, sometimes in the industry. And the best way that I've sort of had to explain to people what it is that makes Lisp interesting is that, if you've ever diagrammed a sentence in school, where you have the sentence and that sort of gets broken apart into the noun phrase and verb phrase and on, that represents the grammar. And this grammar is a separate structure from the text that you're typing in, right? There is this sort of parsing that occurs when you first type this thing in. And the way that the language thinks about what you've typed and the way that you think about what you've typed are different, right? They're separated by that transformation from the plain text to this sort of parse tree. In Lisp, however, they're not, right? There is actually a very close one-to-one kind of relationship between what you're typing in and how the language itself thinks about what you've typed in. And so what that means is that you get to interact much more closely with the innards of the language and build your own sort of domain-specific languages atop the core of the language, and be able to sort of create a surface area that fits your problem very closely, right? The language can sort of rise up to meet the problem that you're trying to solve. And this is not unique to Clojure. Clojure is, again, part of this sort of long lineage. But what makes Clojure interesting is that it builds atop Java, which means that it is able to build atop a very large ecosystem, which is built up over the last, 20 odd years. But also is, just due to its proximity to Java, a more palatable Lisp within the industry, right? People are able to leverage their pre-existing understanding. People are able to sell it more effectively to their bosses. People are able to slip it in, sort of unbeknownst to the people around them, into projects that already are using Java or another language on the JVM language. And it also came out around the same time as a number of essays by a man named Paul Graham, who had popularized the Lisp, has sort of created this little mini renaissance where people were suddenly very interested in this old kind of far-off language. And Clojure rode that wave very effectively. And so that's kind of the short answer. There are many more involved ones, but I think this is not necessarily the forum to get too deep into that.
Yeah, and we'll be coming around to other aspects of it later, in particular related to the philosophy of language and the way you talk about things there in your book and in your talks as well. But before we do that, I wanted to circle back to the question of computer science itself and studying it at university. One of the almost at this point official themes of this podcast, since so many people that I interview are in software, is if you could go back, if you were starting out now, it's probably a better way of formulating it, would you, and you were looking for a career in software, would you formally study computer science at university?
I think I would, but I don't think that I could justify that as a practical decision on my part. I find the academic study of computer science to be satisfying. I didn't find the applications of it to be very interesting. I thought the concepts were very sort of appealing. I've talked to a number of people who have asked me this question, and I think that, the environment in which this decision is being made has changed quite a bit since I made it. But you learn a lot of things and you cover a lot of topics, and most of them end up being irrelevant, right? This is true of pretty much any form of general education, is that most of the things that you learn don't end up being the thing that you actually spend your life doing. The reason that you do it is because you can't predict ahead of time which is the thing that you're going to be doing, right? And really being exposed to all of these things opens up potential paths that you didn't even know existed before. And, within computer science, it's not as broad as, all the possible other fields of study that you could pursue, but it is a pretty broad field. And there are a lot of very deep holes that you can kind of burrow into. And so I think it's somewhat valuable, because otherwise what you do and what you specialize in is dictated more by your first job or your first series of jobs, right? You almost sort of fall backwards into what your sort of domain expertise is. And what the four-year program gives you is a little bit of perspective and maybe an ability to go and choose what it is you'd like to get deep on, right? To make that a deliberate rather than an accidental choice.
And one of the benefits as well, I would add to getting a four-year formal degree at university, is that at least in the North American model, it gives you the opportunity to study other subjects, which is something that you already mentioned that you took advantage of with philosophy. And I wanted to ask you about that. What were your favorite courses in philosophy? What did you find? What sort of philosophy did you find a reflection of yourself in?
By far, I think my favorite philosopher is Kierkegaard. His doctoral thesis, The Concept of Irony, is probably my favorite piece of philosophical writing. He is playful and plays with, I think, a sort of self-negation, this kind of rarefication of his own ideas to the point where they kind of cease to mean anything. And often I think he's actually taught an intro to Buddhism for this reason. But I think that, it's just kind of his whole attitude and his approach to the sort of inquiry that he does, again, spoke to me. Within the book, though, the stuff that I built upon is the early work in the analytic school. And I think that that's another thing which I enjoy, though it veers into this kind of absolutism in terms of talking about like what is and isn't interesting based on what is and isn't possible to have an absolute conclusion about. It's not willing to treat the exploration itself as something which is worthwhile, even if you don't end up getting anywhere. And it was birthed by a bunch of logicians and mathematicians. And so, in the book, I kind of talk about why that mentality is a poor fit for software. And I think it is a poor fit for how I approach these sorts of things. So I think that there are definitely interesting results from the stuff that they explore, but I don't think that the perspective that they bring to the world as a whole is quite as in line with my own.
Yeah, I'm really looking forward to discussing the latter subject later on when we're getting more specifically to the subject of your book. I did want to say, since my first encounter of your philosophical interest was through your talks about the book and through the book itself, I was a little bit surprised to hear you say Kierkegaard was your favorite philosopher. My own sort of responses to philosophy when I was studying it are actually quite similar to yours. There's a certain aridity, and I guess I would say a kind of what I take as a kind of naivete in the kind of analytic or even positivist just approach to the world, like even before you get to any specific philosophy, like this style of mind that I just find kind of unappealing, even though the subjects, like the actual things that are discussed, can be fascinating and meaningful. But yeah, so for someone like me, someone like Kierkegaard, who, for example, had a kind of complex philosophical project in which he wrote under different pseudonyms in order to coherently present different perspectives, is much more interesting and much more appealing, and to me getting at the heart of the matter in a way that, syllogisms about the Barber of Venice or whatever it was are just, not quite as compelling. And so that was so philosophy was effectively a kind of minor for you?
Yeah, I don't think I actually submitted my requested to put in my diploma, but I qualified, and likewise sort of English or creative writing. I forget exactly what the program was, but that also put me in contact with the works of Italo Calvino and Deleuze and Guattari, A Thousand Plateaus, and Donald Barthelme, though that doesn't have really any impact on the book here that we're discussing, but he's just, I think, one of my favorite short form writers. And, there was a period of time where I very much wanted to be a writer. I wanted to find a way to support my writing doing software. And unfortunately, what I found was at the end of a full day of writing code, that sort of exhausted the same part of my brain that would be used to write prose. And, I have friends who are in bands and do software. And apparently that's something that they're able to kind of transition from much more cleanly. And I'm pretty envious of that, actually. But I really haven't written any form of fiction since I started working full time as an engineer, which is an enduring regret of mine. But at this point, I think I've just kind of gone far enough in that direction that I have to accept it.
Yeah, it's really interesting. I've never heard anyone put it quite that way before. But one thing I like to shock my non-technical sort of friends with is that programmers are writers. That's what they do. They write. They're writing all the time. And I mean, essentially, instead of writing something like along the lines of fiction, they're writing arguments. But nonetheless, it is writing. You have to you go off into your own mind. Sometimes the work is invisible, right? Sometimes just sitting there with your head in your hands, you're doing harder work than you do when you're typing. But it's all very much in your head, and it's specifically in letters and numbers and words and things like that. And so I can see that connection between the type of work being the same, being pretty compelling. Before I interrupted your first answer, when you were discussing your career, you were talking about moving on into more senior roles. And one thing, I looked you up on LinkedIn when I was researching for this interview, and I've talked to people who've worked at a lot of different famous companies. You happen to have worked for Fitbit. Mm-hmm. And I wanted to ask you a little bit about what's the company culture like there. I've spoken to people about Google, where I know you spent some time. But yeah, I'd like to just know a little bit about Fitbit.
I have nothing bad to say about the culture at Fitbit. I spent a fairly short period of time there where they had just gone public, and I came in to work on a very particular project. And during that time, so I say that I joined Fitbit because I was actually hoping to finance my work on the book and my work on some other projects by working at Fitbit for a bit and then leaving. Unfortunately, in my tenure at Fitbit, the stock went down by 85%. So I joke that I tried to sell out, and apparently I'm not very good at that. So, but despite that, I think that out of all of the public tech companies that I've worked at or talked to people who worked at or anything, it's probably in the top 5% of healthy cultures where there isn't kind of a focus on tech for tech's sake. There is a very clear understanding of what the technology enables. There also is a nice kind of thing, which is not maybe part of the culture so much as just a structural aspect of the business plan, which is because you're selling people fairly expensive pieces of hardware, their data isn't something that you are incentivized to sell on to other people. And that's very hard to get to find, especially for me, where my sort of specialty is in building high throughput, low latency systems. And most people hear that and they think, oh, you work on ads, which I have, and I didn't enjoy as an industry or as a sort of type of product to build. And so, Fitbit was nice in that it allowed me to kind of flex those muscles, but, towards a different end, basically. And I did want to say, just with respect to what you're saying in terms of programmers being writers, I actually have often said the same thing as sort of a form of kind of being provocative, which is I say there are two kinds of programmers, those who think that programming is fundamentally math and those who think that programming is fundamentally literature. Where I define literature, which, I'm sure that this is not an agreed upon sort of thing, but literature is kind of similar to what Borges says in Tulan Ukbar Orbis Tertius, where he describes a culture that says any time that you describe the universe, you are subjugating all other aspects to one aspect. Right. You're basically pulling out something and sort of eliding all the others. You're hiding them from view. And it's a game, right? It's sort of an attempt to go and make people look at things from a perspective which is maybe familiar, maybe unfamiliar, but it is willfully blinding yourself to something in order to make this one particular thing much more clear, which is not what math purports to do, right? Math purports to be this completely correct kind of perspective on things. It doesn't talk about the things that are ignored, right? It doesn't even have any sort of form of representation there. And so this actually gets very much to the heart of the book, which we can sort of, circle back to later on perhaps. But, do we see software as something which is fundamentally concerned with itself or fundamentally concerned with the environment that it's in, right? Do we acknowledge that there are parts of the environment that are not in our software, but that nonetheless we have to, know about and care about?
Yeah, why don't we talk about that right now, actually? That's a really fascinating aspect of your work. We can get more specifically to the book later, but on this subject, for example, one way into it is you talk about, in a number of places I found, the idea that someone brings part of themselves from like things they've previously done into new things that they're doing. And this can be as mundane as like if you get a new job, you sort of bring the culture of the last company you were in with you. And I think you may have mentioned this already, people who sort of birthed programming were physicists.
Mm-hmm.
And they brought with them something from physics to their approach to software. And I wanted to give you an opportunity to explain a little bit about that, because I know it's partially what I just very briefly, what I partly took away from it was the idea that physics it has a constraint, which is the external world, to which it has to kind of hew. Whereas the environment that a software model is interacting with is itself constantly changing. So an analogy would be, imagine trying to do like experimental science in a universe in which the laws of nature were always changing. Experimental science works perfectly in a universe where the laws of nature don't change, so I can do an experiment on a water molecule here, or 1 billion miles away, or 1 million years from now, and I'll get the same result. But that's a totally different model from what I think you think, or it's a very different model from the way you think people should optimally approach software.
Right. So, this actually kind of, you can draw a through line between our earlier conversation about the analytic school and sort of the physics of the mid-20th century. I think that the early to mid-20th century is a fascinating period in terms of almost every intellectual pursuit, because all of a sudden things just started aligning and making sense. And we understood things, we understood them well enough that we could go and build things that took advantage of this phenomena. We go very quickly from this very sort of crude chemical understanding of how matter works to, say, the transistor, right? And then we go from the single transistor to billions of transistors very quickly. And that one is actually a little bit less interesting. That's almost mechanical, but like the ability to go and make that first transistor, to build upon all this sort of understanding of these very amorphous kind of quantum effects that were discussed there, and to actually be able to do that is amazing. And I think that there was a period of time where people had this positive view that was very hard to falsify, right? Things kept on getting clearer. And if you go and draw that sort of trajectory, it was a straight shot, or maybe even growing sort of exponentially, and there was no clear indication that would ever sort of taper off, right? Maybe we'd just continue to clarify the world and our place in it to ever sort of more dizzying heights. And so, if you look at the analytic school, right, this is the first time they're playing with sort of any attempt to go and make math something which has a sort of firm foundation, right? The Principia Mathematica by Russell, and Frege with his sort of predicate logic, and you sort of keep on sort of going on from there. And so it is, as you said, arid, right? It is, I think, sort of in this, especially from our current perspective, seems filled with this sort of very bizarre hubris and this almost kind of inhuman kind of focus on taking people out of the equation. But I think that it's very understandable in the context in which it existed, and also it has value, right? Like the attempt to go and build these taxonomies, even if we can now look to them and say, oh, well, here's what they were ignoring. These are really admirable projects that people are undertaking. And so if you go and you sort of follow that through, right, from the early 20th century to the mid-century, the computer arrives, right? And it seems like this is a steam engine for this kind of intellectual progress that was being made. And, maybe the only sort of real constraint over our ability to math things was the inability to do enough math fast enough and accurately enough. And now we have this thing that does it for us. And so if you look at the early projects with the computer, which are inevitably tied up in sort of defense spending and a whole other things, and, that's kind of a tricky thing to disentangle. But all these people who were simultaneously talking about how to use a computer to, track radar blips were also talking about how computers were going to become this engine of exploration of sort of this intellectual territory that had until now been off limits to us. And this idea that we could go and we could just apply this sort of very simple logic, but just apply it very quickly and flawlessly, would somehow make things clearer than they had been ever before. And so there is a physics kind of aspect of that, or maybe just more generally this sort of logical, mathematical kind of perspective on it. But I think that, again, in the context in which this existed, it makes perfect sense. However, I think that if you go and then you follow that through to the latter half of the 20th century, which is people's attempt to actually realize this vision that they had, it's largely, at best it's been a mixed bag. And I think that generally you can say that their expectations were completely unfulfilled.
Yeah, it's really interesting. You mentioned that. Thanks for that really great introduction to, I guess, the intellectual, the place of the computer in intellectual history. But one thing you mentioned, one word you used more than once was clarity and versions of it. And one of the really interesting aspects of analytic philosophy, sort of speaking broadly, was an epistemological association with styles of language, which I'm not putting very well because it's been a long time since I've spoken about this, but essentially what they came to see was unclear language was a sign of unclear thinking. And so they had this I think, sort of perverse association of a style arbitrarily considered to be clear with a correct way of thinking. And so this, I mean, not to go too much into the weeds, but this is where you end up with a kind of continental kind of, divide in philosophy between kind of, people who write in supposedly clear styles and people who write in obscure styles. But that it seems to me that there's a relationship between that sort of what we're, I guess, in this conversation calling a kind of physics mindset and wanting to narrow down the range of reference and somehow link that with a stable reality in a way that doesn't necessarily match what needs to be done in software in an environment that's always changing and where things are always new and things like that. For example, I mean, I think this is associated with, you write about how software design is an intractable problem, which is someone with the mindset we're describing, whether it's in analytic philosophy or in, let's say, physics. They don't want, the idea of intractable problems is very troubling, because what does that say about the underlying reality? And so I was wondering if you could talk a little bit about just on that, focusing on that specific idea that software design represents an intractable problem. Why is that?
Right. Well, I mean, to wave my hands very broadly around this, I mean, anyone who's listening to this and hasn't read the book, I recommend that you do, because I'm sure that this is going to present this a lot more in a better order than we are here in this interview. But in general, you can go and you can think about physics, getting back to that sort of idea, as something that's trying to pull every relevant aspect of the world inside of a model. And that works for physics because physics is able to oftentimes sort of reduce itself to, what does one frictionless sphere do to another frictionless sphere? It's able to invent a problem wherein all of the aspects are completely defined, and then hope that sort of can get bootstrapped up into a reasonable prediction of what the real world would do. And with software, we don't really have that luxury because we are dealing with problems that don't lend themselves to that sort of artificial simplification. And so we can't go and pull every relevant aspect of the world within our software, right? We're up against our own mental limitations very, very quickly, well before we even get anywhere near sort of representing the world in our software. And so then it becomes a question, right, again, of this, it's a literary question, which is, what do we get to ignore? Or rather, what can we ignore, right? What are the very few things that we should not ignore? And the problem with that is that if you do that perfectly, right, if you do the Antoine de Saint-Exupéry, there's nothing left to take away, that is beautiful, maybe, but also incredibly fragile, because your judgment there was entirely based upon the context in which you previously or currently exist. And as the world around you changes, as it inevitably does, that invalidates this perfect minimal set of things that you've decided to represent. And the fact that we don't do that is, represented by or illustrated by the fact that, we are building our software atop, decades old pieces of infrastructure, right, which were built to solve decades-old problems atop decades-old hardware, and there's a lot of weird little cruft in there that is like commented out, or paths that are rarely taken, and occasionally people try to tidy it up. But we don't have the luxury of being completely minimal in any of these cases, but we try to be as minimal as possible, because if we let that go too far, then it gets out of control, and all of a sudden we lose our thread, right? We lose our ability to actually orient ourselves within this thing that we've built. And, one of the things I talk about in the book is that, there are actually two different ways you can approach that, which is you, the person who built it, are you still keeping that track of what you've built, right? And certainly, it's very easy to get past that. But then also, if someone new comes along, can they follow you to where you've arrived, right? Or have you basically left everyone in the dust, right? And I think that, it depends on who your audience is. If you're writing a doctoral thesis, you only need to bring along, a handful of people along for the ride, and they're sort of mostly down that path. If you're trying to bring a layperson down it, then you have to be a lot more parsimonious in terms of what you choose to acknowledge and what you don't. And, all of these just kind of combine into this problem where it may be intractable. I mean, I've used that word, and I think it's a good word, but the real point here is that what we don't have, which is a thing that we want, because that sort of pokes at the pleasure center of the engineer brain, is a single scalar value that says, here's how good my software is, right? And then I get to twist something or tweak a bit and say, is it better now or is it worse, right? And we don't have that, and we will never have that. That is an unattainable goal. And I think that is something which people like to treat as a temporary sort of lamentable state of affairs as opposed to an intrinsic part of what we do. And I spend maybe a little bit too much of my book kind of trying to drive that home, because I think that idea that we are just living in the prelude to a golden age of software is frankly holding us back.
And if it's holding us back, what's it holding? How would you characterize what it's holding us back from?
Well, as you say, if you go to this sort of 4-year program, there's a chance to get exposed to a very broad range of ideas. And, in the current curriculum for a 4-year computer science program, there is a very narrow sort of focus, right? There's some mathematics. There's another sort of closely related branch of mathematics, which calls itself computer science. And I took one ethics course when I was there in my 4-year program, which was, talked about the handful of times software has killed somebody and says, don't do that. Did not really, I think, deal with any sort of issue which, even approaches the complexity of the trolley problem in terms of software, which, means that it wasn't much of a course, frankly. And that's about it, right? I mean, there's not really any attempt to contextualize software in the world or to understand the world and how the software that currently exists or, will exist in, within our lifetimes will shape it, right? How these things sort of interact with each other. And I think that if you acknowledge that the tools of mathematics are not sufficient, then you start to sort of reach into the humanities and you can maybe pull that in, and maybe you can have people who don't know that they need to be curious when they're in their 4-year program are forced to be, are exposed to these sorts of things because we acknowledge that this is actually very close to the core questions of software and require, a grounding in this sort of wider set of questions in this broader sort of intellectual tradition.
Yeah, that reminds me I'd like to ask you about abstractions and this relationship between, the model that one's building in a piece of software and the world. But before that, I have just a brief anecdote about, I think that's partly related to what you're talking about, where there's a certain desire to achieve a kind of finality or single solution. I was interviewing Jerry Weinberg a few months ago now, and he talked about how the first computer he ever encountered was himself. So he was there for the ride when all of this got going, and he was there early days at IBM when IBM was becoming a computing company. And he has this great anecdote, which I'll get slightly wrong, but about the executives realizing that there was going to be this thing called programming that was going to be happening. And they wanted it standardized, and they wanted it tied off with a nice little bow forever, so that there would be no more thinking that had to be done along those lines. So he didn't say this exactly, but effectively in their ideal world, there's one programming language, and there's one set of practices, and it's final, and it doesn't change, and essentially kind of becomes effectively automated. And you were reminding me of that. There's people who kind of naturally seem to be driven towards that type of situation as a solution to problems. And then there's the one you're describing, I think, which is can be contrasted to that, where there's ever-evolving contexts that are kind of inherently beyond our capacity to fully capture either in ourselves or in any kind of model that we build. So on that note, I was wondering if you could talk a little bit about your interesting idea of abstractions and how you talk about it in your talks and in the book.
Right. So the commonly given definition of abstraction in the context of computer science, this definition is broadly mirrored in a lot of other fields, but it kind of varies depending on what the field is. It comes from a 1972 paper by Tony Hoare called Proof of Correctness of Data Representations. And, again, notice that in this title it's talking about mathematical proofs, right? And he says that there's this thing called a model, which is contained within the abstraction, which is broadly its sort of representation of what's outside of it, right? This thing is populated by its environment. It's meant to kind of sort of reflect a facet of its environment. And then this model has an interface, and the interface and the model have this sort of flexible relationship because the interface is a very simplified version of what's going on inside of it, right? It exposes certain semantic details but hides most of the others. And the nice thing about that is that now we can sort of play shell games where we keep the interface, but we change the underlying model depending on our needs, right? And so we can go and we can build software atop the interface, and now on either side there's this sort of ability, this flexibility, right? This ability for us to go and sort of change this. But what the paper doesn't discuss at all is, what's going on outside of the abstraction, right? What we're trying to do is we're trying to, in this paper, construct a proof that this is a correct abstraction. And, so this relationship between the model and the environment, right, this is not spoken of. This is just sort of the focus of the book. And the problem with this, right, even the problem with the idea of correctness as a property that we have within Reach is that it is a sort of immutable property, right? That is also, as you said, what physics is sort of looking for, is a sort of immutable truth, right? What is the ultimate unchanging truth that we just have to go and recontextualize within an environment? But fundamentally, once we learn this, then we have it, right? This speaks very much to this sort of I don't know how many physicists that you've spoken with, especially when they're first learning it, but there's a kind of you can choose to find it amusing sort of perspective, which is, physics is at the core of everything. So, chemistry, that's just physics, and biology, that's just chemistry, and psychology, that's just biology. And so really, I'm at the point in all of this, and really you're all just a bunch of, frictionless spheres bouncing off each other. And, I in the most reductive sense, maybe even that's true, though I think it's not, according to the most recent models. But basically that's an uninteresting perspective, right? It's an uninteresting sort of conclusion because the question is not, is this something where if we had infinite time, like we could actually go and calculate what goes on in this clockwork universe? It's what is a useful thing that we can know? What is a heuristic, right, that we can use here to actually interact with the world around us as the world is changing around us, right? Because we are not able to, even with the aid of computers, respond in real time to these sorts of things, in any sort of effective sort of from first principles way. And so I like to say that, mathematics is concerned with being self-consistent, right? This thing does what we expect it to do. But correctness implies that there's a property which survives being dropped into any context. And I think that's provably, obviously false. And so a better question is, what makes a useful abstraction, right? What is an abstraction which is useful in the subset of environments we expect it to be dropped into? And so that's really what the book focuses on a lot, which is, how do we build useful software, and how do we judge whether a software is useful? And if we judge it to be not useful, what are some reasonable steps we can take to kind of fix that? The problem with this is that I'm trying to go and talk about software in general. And of course, there is no general software, right? And I don't want to go and sort of overfit. And so I end up kind of talking a lot about these generic concepts and then rely on the reader to sort of add water and be able to actually turn this into a meaningful kind of framework that they can use to think about or talk about their software. And I mean, frankly, it is still an ongoing project. I don't know if I've hit the mark there, but that's the problem, right? Is that abstraction is useful and it is necessary, because otherwise all you're doing is just recounting, an anecdote about your life. But you're asking more of the people that you're talking to, the more abstract you become. And frankly, I think the book, as it's written, demands a lot from the reader. But I don't know another way to kind of accomplish my goal without doing that.
I really liked the distinction that you drew between correctness and self-consistency. And I wanted to ask you, is that related to your thoughts on the difference between software engineering and civil engineering, where For example, like I can kind of, and you talk about this in something that's come up on this podcast many times, partly because it's of interest to me, is, people often go, well, why can't software work like bridges, where it's like, most of the time, hopefully all the time, but we know that's not the reality, but that's for different reasons. You kind of can solve problems in civil engineering in a way that you can't solve problems in software engineering.
Right. So I think that this question, it's said a lot, and it's one of my most, this is a question which is sort of, at this point, very irritating to me, because I think it's sort of akin to asking, why don't you build a plane out of the black box? Right. Like, fundamentally, we don't build software the way that we build bridges, because we don't build software that solves a single fixed problem that is there for all time. And in the book, in a footnote, I say, this is a bad metaphor. And if you're looking for a better physical metaphor, and all physical metaphors are flawed because you never run out of space in software, right? In software, if you build the ideal home, building it once means that everyone gets to use it. And so it's the way in which these things like deal with scarcity are so different that you're probably just going and misleading yourself by trying to make a metaphor. But city design is at least a closer thing, because the needs of a city and the needs of the inhabitants of its city are constantly changing. And notably, if you go and give everything that the citizens of a city or the inhabitants of the city want, they're just going to ask for more, right? They're going to invent new things that they need to be happy with their lives. And that constantly moving kind of goal, that threshold of sufficiency, is the fundamental property about software that we need to go and sort of acknowledge and maneuver with respect to. And so I think that there's some interesting things about city design, but again, it's a imperfect metaphor for all the reasons that I mentioned, and probably a lot more that I haven't even thought of. So it's used with caution, I guess.
You say it's some of the thoughts you're trying to convey in the book are sort of inherently difficult to convey. I don't want readers or potential readers to be left with the idea that your writing is not entertaining, because it is. And that reminds me of an example I came across first in your talk, where you talk about the idea that possession doesn't imply understanding. And you very colorfully go from the young King Arthur pulling the sword from the stone to Baudrillard, to machine learning. And I was wondering if you could, one of the interesting things about your work is that you have all these different things to draw on that one normally doesn't see drawn upon together. And so I was wondering if you can recall it, if you can walk us through that little sequence of steps from, King Arthur to machine learning.
Sure, absolutely. So there's a really common sort of scenario when you're building software, where you become very familiar with some tool and become very familiar with its shortcomings, right? And learning the shortcomings of a tool is a long and fairly laborious process, because you need to go and use it in a bunch of different situations and get a feel for where it is and isn't effective. But notably, if you go and you look at, say, an open source library, there are very few open source libraries that will say front and center, here's what this library is bad at. Here's what it's not meant to be used for, right? What it will do is it will try to pitch itself as, this sort of all-seeing, all-dancing kind of thing that will solve all of your problems. And if not, that's just because I haven't, come out with, VN+1 yet. And, again, this speaks to our unwillingness to acknowledge that abstractions are sort of contextual things and are not meant to solve all problems, but it's also, I think, just that, culturally, it's hard for us to go and say, I built this thing, I spent a lot of time on it, and here's why it sucks, right? That's a difficult thing for any creator to do. And so what this means, though, is that if we go and we use a thing and we become very familiar with its shortcomings, someone comes out with a new thing, and we look at it and we see the exterior of that thing, right? The README of that thing, which says, here's what I do. And without, acknowledging any of those weaknesses, all we see are the good parts, right? And so what we're comparing now is this very sort of apples and oranges situation where we see through the one thing, right? We see through to all of its flaws. And the other thing, all we see is sort of its nice, shiny exterior. And we're like, oh, well, this is better, right? We should use this. And, in fact, this is a almost kind of cliched kind of example of what a junior engineer will do, right? They'll jump on the new thing because they hate the old thing. And, of course, that just means that, a year later, they'll hate the new thing and, look to the new thing. And the point that I make is that this is a very common sort of pattern where what we focus on is not our understanding of a thing. Understanding is not a property that we think is sort of important when judging something. It's the possession that matters, right? And so, I say that, if we look at King Arthur was able to pull the sword from the stone because he had the right bloodline, because he was kingly, right? He was wise, he was brave. But like those are, at least in the context of, sort of the Arthurian period, totally subjective. And so the only objective fact here is that he holds the stone in his hand, or the sword rather, in his hand. And that's what we focus on, right? In a very real way, the sword is what makes him kingly, is what makes him brave, is what makes him have the right bloodline, right? Another example I give in the book is this sort of concept of the philosopher's stone, where you might think that this is sort of meant to be some sort of allegory, right? Every masterful, alchemist goes and builds a philosopher's stone. But like in the actual literature, it's meant to be this physical thing, right? It's red, it's heavier than gold, it can be ground down, it can heal all sickness, it can extend life. And, the implication of that is, like, if I go and have the philosopher's stone in my pocket and it falls out and someone else picks it up, now they have all the power of a master alchemist, right? They don't need to understand all the things that went into the making of it. It's just the MacGuffin, right? It's the thing. And I think this might be somewhat more common in sort of like Western canon than it is in other cultures, but it's all the same, I think, a very sort of human thing, is to focus on the external sort of aspects of it and to focus on the possession of something as the most important part. And so, yeah, that's sort of the slightly meandering version of what you're talking about there. And I do mention Simulation and Simulacra by Baudrillard.
Which people who are listening who may not have read it will recognize from its brief appearance in The Matrix.
That's right. Yeah. So yeah, I mean, it's a very, but this is sort of the broader point that I try to make here is that, these questions, we talk to ourselves and like we say, oh, well, software, it's new, right? Computers, they're half a century old. We're still just kind of getting our bearings. We have a lot of stuff that we have to go and think about and refuse to acknowledge the sort of broader intellectual tradition we sit within, right? The fact that the questions that we're asking, which is, how do we deal with something which is too big to fit in our head, like, is a millennia-old question, right? There are so many different answers to that and so many perspectives on that and so many things which we might read and might recognize as a distorted reflection of what we do on a daily basis. But most people who study software will never come into contact with that unless someone kind of shoves it in their face, right? And I think that the only real antidote to that is really the sort of the conference model where people go up and give talks and kind of give a small little glimpse into a different path of study that they could have taken that's sort of digestible within 40 minutes or so. And I think that's good, but it's certainly not it's not a solution, right? That's a Band-Aid.
Yeah, thanks for that. Your invocation of simulations and simulacra drew together a couple of interesting things for me about this idea of possession not implying understanding necessarily. One is that one of the fascinating things about that book as a historical artifact is that it was about reality TV and the kind of the first instance of reality TV, I think. And so what Baudrillard is partly talking about is how the representation of something, and this is crude and wrong, but the representation of something can make it real in a way. It also reminded me of one of my favorite examples of that same type of thing that I wouldn't have put in the terms of possession doesn't imply understanding, although that's better than the way I would normally put it, is people often assume that a businessman understands the economy, or a business person, I should say. because they possess a business, because they're presented as being associated with money and its accumulation, they both are assumed and assume of themselves that they understand this thing that no one credibly claims to understand, which is the economy, because it's too big for us. But there is this, and as you've even invoked, there is this, we all have this very deep drive to have things be kind of containable and understandable. And, the idea that you can have these kind of, you can do something actually really easy, like start a business. I didn't say succeed at it, but starting one and owning one is not hard. And then you can sort of present yourself as even to yourself as understanding this giant thing. It's just very tempting to have these substitutions set up because they make us feel better about ourselves and the world when things can be beyond us.
Right, and I think that, there's a lot of commentary we could go off and veer off into, the fact that in, I think, the gold rush, people who, found a successful gold mine here in San Francisco were not then asked, you seem to understand so much about money, and yet we seem very willing to ask that same question of someone who's, started a startup and, in many cases was just, in the right place at the right time with their particular idea. But I think that, specifically with respect to software, this focus on this idea of possession is especially dangerous given the sort of idea, like the current sort of fascination with machine learning, which is, I think, something that you mentioned I didn't actually go into, which is we build this thing which has these sort of emergent properties, and we think that because we defined some aspect of how it was created, that, our understanding somehow carries through to all of the consequences of our decisions, right? That by defining the seed, we understand, the plant or the forest or the, all the other sort of consequences of this one action. And I think that if you go and you talk it through, people would be like, oh, well, no, that's not actually what I think. But I think that we don't poke our own sort of, hot air balloons of self-regard there very often. We're not sort of wired to do that. And so we will go and we'll do stuff. And I think that, we're starting to see this now with self-driving cars, which is, frankly, I think a little bit terrifying. And the engineers that I know who are knowledgeable about these things, more knowledgeable in most cases than I am about the sort of specific techniques that are being used, sort of are split 50-50 between sort of horror and kind of glee in terms of, the fact that there's so much new stuff to figure out, but also we're just kind of pushing forward without first pausing to figure it out, right? And again, we can look back to sort of the early to mid 20th century where, in the Manhattan Project, they had a ball of uranium, a little sphere that was like in the entryway to one of their buildings, and people would rub it for good luck. It was like, it was a little bit warm to the touch. And, most of the physicists predictably died of cancer, at a relatively young age, because they understood it, but they didn't really understand it, right? They didn't understand everything. And some of the things that, some of the factors there probably wouldn't have been understood even if they had tried without like decades of actual study, and they didn't have decades, right? And so this was a sacrifice that they made. But again, there's that same kind of hubris, I think, at play there, and it worries me. It worries the hell out of me.
That's interesting. I don't want to go down this. I do actually want to go down this road, but I know we probably shouldn't for more than we'll time box it to just a couple of minutes. But this is actually a preoccupation of mine in particular. And one thing, so I guess my brother and I have a joke that there's like an infinite number of ways you can divide the world up into two types of people. And I'm definitely on the side of 1 million people are dying a year in car accidents. What if there is a problem with, us not knowing what's going on inside the black box of machine learning, that's a problem that I'm concerned about, but like it's sort of inversely proportional to my concern about what is it about us that lets us live with this current situation as though it's okay, which is just a way of kind of flipping, talking about an entirely different dimension of a problem.
And I don't have a good answer to that. And this gets back to this sort of thing where like we understand very deeply the shortcomings of the current model and understand only the potential of the new one. And so, like, maybe you could say, well, it couldn't be much worse, right? Which is the sort of antithesis to, the devil you know. But I think that it's hard, and, any decision we make there is pretty much by definition not a rational one. And I think that, also as accidents occur, as, they just did recently, we can go and we can sort of reevaluate sort of the different approaches here. But it's more worrisome to me because there is this veneer of mathematical certainty sort of smeared across the top of this enormous opaque thing that's just kind of accreted. And that's not the right way to be thinking about that, right? And so, I mean, maybe we go and we if we looked at that with clear eyes, we would still do exactly what we're doing right now. But the way that we're sort of understanding this, the sort of visceral understanding we have of these models that we're creating are not, I think, accurate.
You mentioned piercing the hot air balloon of self-regard, and that reminded me of something you wrote about narrative fallacy in open source. And I wanted to take at least a few minutes in this interview because I know you've created some open source libraries, and that's an important part of what you've done. And I wanted to ask you about that specific question. What is the narrative fallacy in open source, and what's your rather pointed opinion about that, assuming it hasn't changed since you wrote them?
No. I mean, I spent a lot of time thinking about that because, I mean, so I've spent a lot of my life doing open source work. And I think that for a while I was doing it without really even having articulated to myself why it was a thing that I felt like I ought to do. It took me some time to kind of reach any sort of level of clarity on that. And I mean, so there is this kind of very well-defined narrative, which is from this really odious guy named Eric Raymond, who, reflects kind of the worst of the early parts of the libertarian internet. And but he's famous, and he's famous because he basically built this narrative wherein he was the archetypal sort of hero, which is to say that someone who had a problem that they were trying to solve, and he inserted himself into this vast network of people who had similar problems, and sort of in this emergent way, they solved the problem in a better way than any individual person could have, right? And he coined this term called Linus's law, which was sort of meant to be about Linux, which is, I'm going to get the exact text wrong, but it's with enough eyes, every bug is shallow. And the idea is that basically, the law of large numbers just makes it possible for us to write better software than any one expert could ever do. And, he's not wrong, but the narrative fallacy in terms of how I said this is that it presumes that basically because this happened, right? Because the Linux kernel was created, because this enormous community of people sort of built around this, that was either inevitable or even desirable to most people who create open source. And, this kind of gets back to this, you could go and talk about any creative endeavor, right? Anyone who's going and writing a little bit of fiction or writing whatever wants to create the great American novel. Anyone who's writing an essay wants to become a public intellectual. These sorts of outcomes, they exist, but they're not the common outcome. And to assume that basically there is a strict hierarchy where some people just got further up that single ladder than other people is kind of absurd, right? If you stop to think about it even for a moment. And so, towards the end of my stint of being very focused on these sorts of open source projects, I started to get a little bit burnt out, and I realized that the maintenance of the project, the kind of construction of this community around it, wasn't what was motivating me. What was motivating me was that this was an exercise in understanding something, and once I understood it, it wasn't that I would run away necessarily, but it lost a lot of the allure for me. And, In some cases, I would learn enough and I would have this kind of horribly incomplete thing and I would never even see the light of day. In some cases, it would be something where, in order for me to understand whether or not I had built something that was useful, I had to see if people used it, right? Whether or not it fit their needs, and then go and adapt that and then update my own understanding. And I can credit, I think, a lot of my insights, such as they are about software, to this period of my career where I was extremely focused on building these abstractions, building these interfaces that were meant to be these sorts of general solutions to these problems, and then just seeing if people came to me and said, this doesn't solve this particular case that you weren't even aware was a thing before. And I'd have to kind of fold that in and figure out how to sort of, extend what I had built to fit whatever it was that they were trying to do. But that's it, right? I wanted to learn. And it was a fundamentally kind of selfish, greedy kind of motivation there. And in this essay I wrote, which is called In the Shadow of Giants, or Standing in the Shadow of Giants, was basically me just kind of talking about the fact that I think that most people who do open source work are not trying to go and build a log cabin and then wait for a city to grow around them. I think most of them want to be on the frontier. And that frontier is a moving target, which means that as people start to show up, they inevitably get pushed further out. And this is absolutely a thing that you can observe in any open source community. And the fact is that I think that we understand this as part of the sort of social mechanics, but we still have this one narrative that was like posited in 1998 as like the one true thing that open source projects are aiming for. And so I think that, we need to go and we need to be more honest with ourselves. And I think that we need to not just have this sort of implicit understanding of what goes in there, but actually start to like create a vocabulary for this, because now, like, if we have a shorthand for it, then people can actually have meaningful conversations. And, this gets back to sort of the question of the questionable merits of the analytic school, because I lean on that pretty heavily in some parts of the book. But they provide a taxonomy. The taxonomy is not perfect. It purposely ignores a lot of nuance there. But, a reductive taxonomy is better than none at all, because without that, we're just kind of reduced to, making grunts and pointing at things.
And actually, that's a really great segue into my next question, but I'm going to preempt it with just an interesting observation about that essay. I really enjoyed the way you set it up with the image of, you don't put it in these terms essentially, but an association that people have historically drawn with the advancements on the American frontier and advancements in, let's call it, civilization. And you have this great little joke where it's like the only problem was that when civilization arrived on the frontier, the frontiersmen kept moving, or some proportion of them just kept moving, because that civilization was the last thing they wanted. That's why they were on the frontier in the first place.
Right. And I think that that's the thing, is that and we say, oh, wow, these people, they were such pioneers. They so clearly wanted the American way of life to go westward. And no, they wanted to escape it. Right. They wanted to get away from this structure of civilization. And maybe at some point, they had enough property that they wanted someone to come along and, protect it for them. Right. That's not to say that people's understanding of what they want might not change over the course of their lives, but to say that basically there is this sort of collective urge towards the creation of this enormous, complex, sort of intertwined thing is ridiculous, right? And if we go and we say that and again, this is narrative fallacy, which is like the end, is prefigured by everything that was coming before, and everyone knew that that's where they were going, and they were trying to get there, as opposed to that was just kind of an accidental result of all these things that people did for reasons that are diverse and sometimes antithetical to the actual outcome.
I also wanted to just very briefly before moving on, thank you for I actually know I don't know what kind of I might be stepping in with this, because I've been in the startup space for a while now, but I came from a non-technical background, and I remember the jarring moment when I was reading Eric Raymond's Cathedral and the Bazaar, which I was, thoroughly enjoying, and then he referred to Ayn Rand as a philosopher, I can see you, SMH, And I thought, both I was kind of, a little bit of, puke in the back of my throat, but at the same time, it was like, I know that there's some intellectual background that he's coming from that I don't share. And when you mentioned just now that he was part of a kind of libertarian part of the discussion, that really actually settled a long time question I've had that I didn't have an answer to. So thanks for that.
Yeah, I mean, if you're actually curious about this, like he was a maintainer of this thing called the jargon file for a very long time, which was his attempt at defining like what is the ideal, like, quote unquote hacker culture or hacker personality or whatever, and was basically, his way of saying the ideal archetype is me. It's me. Hi, I am, the archetypal hacker. And he's not a bad writer. And he is not like completely devoid of valid points, but I mean, speaking of hot balloons full of self-regard, like that's him, right? And it's frustrating because I feel like his whole sort of, narrative that he built around his like heroic journey in the open source community sort of hijacked a lot of the conversation in a very unproductive way, and hijacked a lot of people who were first starting out, because people will go and they will emulate, like for the same reason that people will go and read the biographies of famous, physicists or scientists or whomever, and people will try to go and make the early points of their lives coincide with the early points of their hero's life, even though that doesn't actually control the outcome in the least. And I think that, you have people who, you can go and you could admire some small aspect of what they've done, but then to go and try to emulate them is counterproductive at best.
On the subject of productive emulation, moving back to your book, you had a really interesting approach when you started thinking about writing your first chapter, as I understand it, which was, I want to write about naming in software production or development, and I want to not necessarily start entirely anew. What if there's a framework out there for naming and for understanding language that I can draw upon? And you as you mentioned just a few moments ago, you found a framework like that in analytic philosophy. Specifically, you talk about Frege's concept of a sense. And I wanted just to give listeners an example of actually how useful this sort of to most people kind of obscure aspect of a philosophy of language actually can be when you're thinking about like doing something very pragmatic involving other people, where you're building a shared vocabulary, which is naming things in software. So yeah, could you talk a little bit about that, about reference and sense and things like that? Sure.
Yeah. So the classic way that sense is presented. So in the philosophical discussion of names, you have a thing which is a sign, which is like the textual representation of name. And you have the referent, which is the thing to which it refers, right? And, there were a lot of different sort of takes on this. Plato in Cratylus says, names actually reflect your inner character, which apparently now, if you have a name like from Dickens, which is like, I can't even think of a good Dickens character name now, but
Mr. Crook.
Yeah, sure, right. I mean, yeah, let's go with the obvious ones. Those are cratylic names, right? Names which are sort of meant to go and establish who they are without you even knowing who they are yet. And that obviously isn't true. And so then like the kind of the philosophical consensus was, any sign can point to any referent. It's just kind of this arbitrary thing that we agree upon, right? Dartmouth is not necessarily at the mouth of the Dart River. If the Dart River moved, you wouldn't have to rename Dartmouth. Like it's just, this text happens to mean this thing. And so what that means then is you can have multiple signs that point to the same referent. And that these things just become sort of synonyms for each other. But what Frege pointed out was that in ancient Greece, they had these two heavenly bodies, which were the morning star and the evening star. which were, a heavenly body that we're seeing at the beginning and the end of the night, both of which happened to be Venus, but they didn't know that until a fair bit later. And so he said, well, we could construct something where we would say, Homer, who was, in ancient Greece, thought the morning star was the morning star is this kind of, tautological, obviously true sentence. But Homer thought the morning star was the evening star is not, right? These sentences are different, and therefore these different signs that point to the same thing are not just synonyms for each other. They differ in terms of their sense, which is how they refer to that thing, right? And so I took that, and by the way, this is, a pretty big oversimplification of a very nuanced subject. I should note that the names chapter is available for free, and so if anyone wants to go into this, you should just go and download the sample chapter. But in software, you can kind of draw a similar thing, which is, we don't have, as they do in philosophy, sort of counterfactuals, which is like, a common one is like, what if Nixon wasn't Nixon? Because they talked about this a lot during the 70s, actually. And they said, what if Nixon weren't president? Would Nixon still be Nixon? And we don't have that, right? We don't have alternate universes in which our code base is different, but we do have this constantly changing set of implementations, right? We have these things that are hidden beneath the interface. And they change, and their nature changes, and yet we still use the same word to refer to them. And so then the question becomes, okay, well, if we go and we have a list, and the list is a linked list, or the list is a sorted list, or the list is an array, or whatever, is it still a list, right? What is the thing that holds us together? What allows us to go and talk about these things interchangeably? And that thing is, in my sort of mapping of this philosophical concept onto software, is the sense. The sense is the essential quality that is that sort of through line that remains valid even as our software changes. And so if we talk about like an identifier, a unique identifier, often people will use a UUID, which is just a very large random number that is extremely unlikely to have a collision. And, we start talking about this, we say, okay, well, is our ID represented as a number of this particular size, or is it just some sort of arbitrary string, or what are the things that we know to be true now versus the things that we believe to be will be true forever, or will be true for so long that, like, if it ever does change, we'll just change what we call it. And that's difficult, right? Because as software implementers, we have to go and sort of cleave our understanding of something down the middle, because we both understand what its sort of externally visible semantics are, but also what it is underneath the covers. And when we're talking about it, we can't go and allow our understanding of the innards to sort of leak outside, because now we are enshrining these incidental implementation details as permanent features of the thing, right? And so the sense is not something that our software enforces for us, because it's captured not just by the code, but by how we talk about the code and how we allow that code to change over time. And, there are type systems, but there's no type system that constrains what the software can become. And so fundamentally, the sense exists in our head and nowhere else. And so this, again, gets back to this sort of intractable thing, right? Because, like, we are the stewards of not just the code, but what the code becomes. And therefore, the onus to, like, make these things change in a way which is reasonable is entirely on us, right? It can't just be our tools. And that's, again, probably clearer if you read it while it's written down, but that's sort of the gist of it, I think.
I can't resist the temptation to talk about an example of leaking out, which is kind of a crude version, I think, a crude version of what you're describing. But internally in LeanPub, we have a joke about is-gift design. And so what happened was we discovered that, so the code for when you're gifting a book has is_gift. And the way that was then presented in the UI with a little tick box to customers was is_gift? ? And we do, I won't go into it, but we do have other, and we sort of, these things can become a shorthand within the internal discussion. So, the sense of is_gift in LeanPub internal kind of coding discourse is this, idea that, an example of things, the way you name things in the code can actually affect the way things sometimes get presented to people, which, like I said, is only a very crude and kind of marginal example of what the deeper problem that you're describing.
But I mean, this happens everywhere, right? And what's interesting, I think, is that end users have gotten very used to having these weird little software isms kind of leak out into the way that they interact with it. And to a certain extent, like as they become more, literate, I think that's probably the wrong word, but more familiar at least with the sort of idioms of software, these things become comprehensible, right? And so this, again, is a moving target. It's probably a generational moving target, not like a year-to-year one, but like still, people probably will start to just kind of accept these weird little like quirks of the database schema becoming, how these things are exposed, right? And that's maybe okay, but it's again an example of something I think that we don't spend very much time thinking about.
That reminds me actually of another example of where naming can be so important is just in the not necessarily like there's one version of it is how is the customer out there in the environment interacting with it through the interface, but there's how are things discussed internally, and how do you keep that distinction between what the user is experiencing and what you're saying in your code. And so we've got an example in the way LeanPub is coded that sort of preoccupies me, where we used the natural name for the thing in the code, and then when we're trying to talk about that aspect of LeanPub, I always get frustrated in a way my colleagues might not, but because I see this distinction being lost between what the customer is thinking when I'm using this word to refer to the customer-facing thing and what the customer thinks they're interacting with. That's wholly distinct conceptually from whatever's going on in the code, but those we can end up being confused about what we're actually talking about changing or talking about doing, because we use a natural what you would, or I mean I'm sure it's not coined by you, but you would use a natural name to refer to a piece of code, and for this very reason, or partly for this very reason, you talk about the importance of using synthetic names, and I was wondering if you could talk a little bit about that.
Yeah, so I mean the basic idea is some names lend themselves to sort of a metaphorical or analogical kind of understanding, right? It's a word that we know what it means in the real world. If we call someone a user, that is sort of shaped by both the dictionary meaning, but also like all the times we've seen that word be used before in other code bases at other jobs we've had. And so as a community, as a sort of a culture, we have like a fairly decent understanding of what that means. I recently was doing some consulting for a company that handles other companies' customer data. And so they cannot call their customers because that refers to the sort of thing. And so they use the word tenant. Tenant is the people who are actually paying them money. And, in my sort of conversations with them, I had to go and train myself to go and like do this. And when I said customer, to correct myself if I meant to correct myself. And, so like these sorts of things lend themselves to this kind of and that's actually a good example of the distinction here, which is, the customer is a very natural name. We know what that means. But it also, in this particular context, is misleading, right? The customer is actually their customer's customer. And so we have to come up with this new name, this thing that is not going to lend itself to that same sort of misunderstanding, which is tenant, which is sort of it has some sort of reference to a meaning, but it's largely just this kind of arbitrary term they chose, right? They could have called it anything. And that's important in some cases, right? But like if someone comes in cold and someone starts talking about tenants to them, they won't know what they're talking about, right? That word only makes sense if it's defined up front or defined within the first few sentences of like its use or whatever. And so, in software or in computer science rather, there's a very vibrant sort of field of study in type systems, type theory. And this is built atop something called category theory, which has this kind of menagerie of names that are called like monad or monoid or, all these other sorts of things. And these names were chosen specifically because they don't mean anything, right? Specifically because they did not want to have them come laden with some sort of potential for misunderstanding. And the problem, though, is that, if you go and you create the synthetic name, this name which does not lend itself to this sort of metaphorical understandings, that people try to make it metaphorical, which is why there's this whole ongoing joke about people making, monad explanation blog posts where they try to go and come up with an analogy. So like a monad is like a burrito, is like a writing desk, is like a whatever, right? And that's, again, just because that's something that's very natural and very human. And so you would like to think, so back to your sort of thing about like the analytic school, Frege actually was, for most of his career was looking for what he called the Begriffsschrift, which was a perfect language, a language where at each sign had only a single referent. No referent had two signs. No sign had any ambiguity. There's a good book by Umberto Eco called The Search for the Perfect Language, which is like a bunch of different people trying to do this over the course of history. And it's, again, the very understandable kind of instinct, because you see this sort of muddiness and you want to replace it with clarity. But we don't think clearly. People don't think clearly. People think in a way which is fuzzy and sort of intersecting and makes these sort of broad intuitive leaps. And when we're creating something which is an interface for them, and that's what software is, it's an interface for sort of how we reason about these problems, we want to build on top of that, not try to like cut that off at the knees.
It's funny you brought up the example of monads, because having when I came first to software startup world, I did have a little bit, as we talked about already, I had a little bit of a background in philosophy, and so I knew what a monad was from Leibniz, and so I was like, like my own version of that joke, just incredibly confused, because the word actually did have some meaning for me, and it took me a while to realize, like this, like you were describing, like, this is actually being used because it can be an empty vessel. But this whole discussion reminds me of something really interesting that I've thought about a little bit in the past, which is that there's a certain level of specificity beyond which it is impolite or unconventional to go when one is using language. Mm-hmm. And I find this to be the source of all kinds of problems in day-to-day life, that people, because they're unwilling to go to be more rigorous in their use of like just day-to-day language, and especially when you start dealing with teams, a word can take on a certain meaning, but then someone might use it to mean something else briefly in a conversation. And I've seen this happen. If you don't let it go, if you do let it go, then in like a year later, 2 years later, or the next time you have a meeting with the big boss or whatever, that slippage in usage can come back to bite you, and can come back to bite your team. But at the same time, it will not come back to bite you. It will bite you right in the moment. If you go, by the way, you used the word such and such to mean such and such when actually it means such and such. Like, unless you're lawyers, people are probably going to get actually angry with that or laugh at you. And so you actually take a personal hit if you're trying to protect the team. And it's got this sort of like, it's got this feedback effect of negativity, because it's the problem itself is one that people are uncomfortable even trying to solve. And so bringing it up not only brings up the problem, but that problematic aspect of it, if that makes any sense. I mean, I'm demonstrating the very problem in the way I'm trying to describe it.
No, I mean, but it's really a big deal. And I mean, as I've gotten more senior, like, there's some sort of predictable things that come with that, which is that you spend more time in meetings, you spend more time in kind of like broader strategic kind of conversations. But like a thing that I wasn't expecting, and, I don't think this is just because I'm like a fussy person, is that I become sort of the informal defender of the nomenclature, because I have the standing to do that, where people are not going to go and, bite my head off if I go and do this. And, there's a polite way to do that and a kind of impolite way to do that. And I think that there's a little bit of kind of social grace required to do that well. But at the end of the day, if you don't make people habitually use the right word, then it'll start slipping to emails. It will start being in like little side conversations, and eventually you are talking past each other, sometimes in a way which is like fundamental and dangerous. And so, there's not, our brains aren't constructed as proofs. You can't go and, first day say, here are the lemmas that underlie our personal conversations with each other, right? Here is the, thing. I mean, it's not tractable, but it does give you some understanding of like why Wittgenstein was like writing, the way that he did, because he wanted to write in a way that didn't brook any ambiguity. And so, I think that has value in moderation. And so I think that, again, this is back to this thing, which is, I said, either software is mathematics or it's literature. And obviously it's both. And you have to go and kind of allow them to break through in ways that are healthy in like different parts of your project, right?
Sorry for the nerdy distinction, but were you referring to the Wittgenstein of the Tractatus or
Tractatus? Yes.
Okay.
Sorry, I should have been clearer. Yes.
No, that makes sense. Just so anyone listening who knows the distinction between Wittgenstein 1 and Wittgenstein 2 knows which Wittgenstein we were referring to using that word. That reminds me of I've got this sort of little saying about people who stand in doorways. Their experience of the world, of other people, is one that's kind of fraught. And if you don't know, it's because you're always standing in the doorway or stopping at the bottom of the escalator or something like that. You're going to think the world is different than it really is. It's just that way for you because you don't attend to, or you're not certain aspects of your behavior, or you're not circumspective enough. And I like that. And now, like, there's something about, like, I'm sure you've got, encountered people who say things like, why does this always happen to me? And it's like, well, why don't you think about that? You know what I mean? But with this universal problem about looseness with language, just becomes even more exacerbated, obviously, in the context of software, where looseness of language makes something not work, like literally not work. And you can't,
right.
can't. It's sort of an easier environment to correct the problem because you actually can't get away with it beyond a certain point.
But it is, that ambiguity and that looseness is extremely valuable in the earlier phases of software. And actually, this is sort of an opportunity for you to talk about this because, I was talking about this kind of idea, this resonance, this sort of self-recognition I found in certain things, and my sort of frustration in not being able to explain that. And it took me most of my time that I spent like kind of reading and trying to do research for this book. But I eventually found this book called The Tacit Dimension by Michael Palumi. And Palumi was a chemist who later in his career decided he wanted to become a philosopher of science. And he was trying to go and talk about what is it that precedes the hypothesis, right? Because if you look at Popper, you look at Kuhn, you look at all these other people who are trying to talk about science and the scientific method, they would talk about, okay, well, you have this thing and you falsify it, and if you can't falsify it, it becomes a new prevailing hypothesis, and then there's a paradigm shift and all that sort of stuff, which is sort of downstream of that. But what they didn't talk about is, well, okay, so where does that hypothesis come from? Because you could have any hypothesis, right? There are infinite hypotheses, and yet you chose this one, which happened to be better than the prevailing one sometimes. And people didn't talk about that. It was kind of a impolite, and it's making a rude noise in a large gathering, right? Like it's something that just wasn't really spoken about. And the way that he talked about this was what he called tacit knowledge, which is something that we understand, but we don't understand directly. We understand it through something else that we do. And so, the example that I've given is, I'm speaking right now. Clearly, I know how to make sounds with my vocal cords, but I'm not focusing on that. I'm focusing on my words, right? I'm thinking past the physical act of speech to the actual ideas that I'm trying to convey. And I think past that so readily that I don't actually know what I'm doing. Not in any sort of way that I could articulate or try to refine. And the only reason I would do that is if I wasn't speaking well enough, right? If I had some sort of impairment, or if I were a professional stage actor or singer or something like that, where, simply being adequate is not enough. And I think this is true of most things. And we have this kind of inarticulate understanding of things where we are sort of in a vague kind of nebulous range, and we're trying to winnow that down to something which is more definite. But the expectation that we arrive fully formed out of like our heads at the software that we write is absurd. And I think that similarly, my expectation that if I read something and it spoke to me, it affected me, the fact that I could go and affect someone else with that, right, is also not reasonable. I have to be able to distill that and to sort of turn that back and kind of be able to walk someone through this intuitive leap that I just made. There's actually a fun thing that I learned is the root of the word heuristic comes from the Greek heureka, as in I found it. And I think that that's what it is. A heuristic is this intuitive leap to something that seems to work and we don't know why. But that's not the end of the kind of story. The next step is for you to piece your way back, find a path back to this place that you sort of leapt so that you can take someone there with you, right?
Speaking of things being fully formed or not fully formed, I think that's a good opportunity now that our interview has reached feature length to move on to the last part of the interview and talk about your experience writing, and in particular your experience writing on the LeanPub platform. I believe you published your book in progress, and you marked it 100% complete very recently, so congratulations.
90%. Yeah.
Okay. And I wanted to ask you a little bit about that. Why did you choose to publish your book while it was in progress, and still is in progress?
Well, there are a couple of things that went into this. So I didn't go to LeanPub because it allowed for the incremental publishing. I went to LeanPub because I couldn't find anyone who had gone through the existing technical publishers and had anything good to say about them. And in fact, I heard stories from a lot of people who had written books and said, specifically, if I did it again, I would go on LeanPub. And so that was my first encounter with, LeanPub as a thing. And I looked on it, and I knew Brian Merrick, who I know you interviewed fairly recently, and saw that he had published a few things on there. And so I asked him if he had any sort of complaints, and he said no. And so at that point, then I sort of had the choice of, do I just go and write the thing and wait until it's done and then just sort of put it up there in all of its glory, or do I kind of do this a little bit more incrementally? And frankly, I think I'm just kind of used to now through my open source work, kind of working incrementally in public. But also after I wrote the first chapter, I had sort of a moment where, I was kind of pulling a lot of things together there, and it reflected how I thought about it. And I was excited about it because I think it was the best articulation of my understanding of naming that I had arrived at. Like the act of writing it had forced me to make this sort of tacit knowledge explicit. But I had no idea if it would work for anybody else. I had no idea if this reflected how other people thought about names or if they would find it to be a useful sort of approach. And so for me, it was just kind of a sanity check because I showed it to a few of my, closer friends, and they're like, yeah, sure, it's fine. But that's also not, that's a narrow group, people who by and large are about as experienced as I am. And that's not a great sort of sample to work with. And so I figured the best thing to do was just to put it out there. And so my first version of the book that was published was one of 4 chapters complete. The first chapter was completely free, so there's no reason for anyone to pay me any money for it. But then people did for some reason. And so I took that as a good sign and kind of went on from there. But that was 2 years ago. So I've been working on this for a while.
Yeah, it's interesting you mentioned something being available for free and people paying for it anyway. Some of LeanPub's most it's something that people often find surprising, and we did a little bit too when it first happened. But some of our most successful books in terms of revenue are free. Mm-hmm. Have a minimum price of free, mm-hmm. And that's something that is very, very interesting. to watch happen, and sort of it's something I enjoy thinking about, even though it's sort of difficult to kind of get without polling people, and even then it would be indeterminate, but it's difficult to get data around it. And it seems to be partly, at least my pet theory, is that there's two driving factors behind that. One is the royalty rate that LeanPub pays, that we put on display as, like, we show two things when you're paying. You pay and author earns. And one thing we discovered shortly after implementing that was that people were sliding around the author earns because the difference between author earns and you pay wasn't that high. So we get people paying odd prices like $11.67 for a book because that, given our royalty rate, turned out to be $10.
Right.
A price no one would ever type in, And the other thing is that giving people that choice with the variable pricing model, where you can have a minimum price of free or something else, and then you can have a suggested price. Giving people, my pet theory is that giving people that autonomy, that option to choose, actually encourages them to pay money. Because they then feel not like it's being taken, but like it's being given. I'm not sure if that's true, and I don't know if I could prove it if I were asked to by someone at Google or something like that. But that's my sense of why that happens.
Well, and I think it's very curious because frankly, I hadn't thought about the price of a book that carefully up until the point where I started writing one. But I mean, even for a book like mine, which is fairly short, it's only 25,000 words, it's still a pretty significant investment of the reader's time. And given any sort of hypothetical hourly rate for this person, the time that they're investing in the book is far more expensive than anything that they could possibly pay. And of course, mine is in the $25 to $35 range, which I don't think I could go and I could double that or triple that and be like, well, it's still cheap compared to your own time, because people don't think about it that way. But I do think that in technical books specifically, it is a little bit easier to make a case for, here is the dollar amount of value I'm providing for you. And I think a lot of your most successful books, correct me if I'm wrong about this, are technical in nature.
Yes.
And I think that's that's reasonable, but I think that also, people are not fully rational. I have had some people tell me, how on earth could you expect me to pay this much? This book is so short. And I'm like, well, do you want me to use up more of your time? Like, I don't, like, it's a interesting, slightly irrational kind of space that you're navigating there.
My last question, it sounds like it might be the end of the workday where you are. So my last question is, if we could build one thing for you or fix one thing for you, what would you ask us to do?
This is super low level, but in the Markdown formatting, you can use like the backticks to represent code formatting. And it'll still do line splits there. So occasionally it'll like go and hyphenate things for me and stuff like that. And that makes it, I think, harder to ultimately understand what is kind of going on there, because it's not clear if that's the thing with the hyphen or if the hyphen is like, just part of the sort of publishing. But I mean, like, I have to say, I'm very happy with the degree to which LeanPub does not allow me to be fussy. I'm not sure if you're familiar with the sort of story of Knuth, sort of trying to write a book about software and then spending a decade writing software to help him write a book. And that's how tech came about. I think you guys actually use LaTeX to do your sort of stuff. So, I mean, I'm very prone to those sorts of yak shaves, and I think that I probably would get very deep on the questions of formatting if I was allowed to. And so, that's a small complaint. I think that for the most part, I like the fact that I don't have very much control. I have to focus on the text and just kind of let that stand for itself.
Thanks for that answer. That's actually, I mean, as you know, that is the reason that we do sort of on purpose not give everybody everything that they want, and it's sometimes hard to give that message. I mean, I know I personally can end up in the formatting rabbit hole for a long time, procrastinating, and so it's always this very fine line that we have to walk between giving people everything that they want and not giving them everything that they want, because it might be what they want, but it's not what they need.
Right.
And yeah, I think what you're talking about is an instance where you need to manually line wrap in order to make the hyphenating not happen. I'm not a computer programmer book author myself, but my colleague Peter has written a few, and he's got some good answers for that. So if anyone's interested in that detail of why LeanPub works that way, you can email us at hello@leanpub.com.
Yeah, and please, I mean, if to anyone listening who's sort of on the fence, you really lose nothing by trying it out. And I think that, even if you were to want to go and have sort of finer control over this, as a platform to go and sort of build this up and validate whether or not what you're writing has value to people, there's nothing better that I'm currently aware of. So, I'm very grateful that you guys have done what you've done and have made the choices that you have, because I think that it's helped me. I mean, I've made slow progress, but I think I could very likely have made no progress at all under other circumstances.
Well, on that note, thank you very much for that. Thank you for taking the time to do this interview. I really enjoyed it, and for being game for all the questions on so many different things. And thanks, lastly, for being a LeanPub author.
Yeah, well, thank you.
Thanks.